This is a brief video setting out Euler Problem 2 from 2020, and the problem was find all the odd numbers between 500 and 1000 which have exactly 16 factors. So we are obeying this inequality for our number n, or numbers, and there's an important theorem you need to know about powers, which I'm going to cover very shortly. So these are all the prime numbers which we are likely to use. We've omitted 2 because we're asked to find all the odd numbers between 500 and 1000, and the prime 2 will give an even number. So let's have a look at 2 squared, 3 cubed, 4 to the 4, p squared, then finally p to the n. Well, 2 squared is 4. We have 1 is a factor, 2 is a factor, and 4 is a factor. 3 squared is 27. We have 1 is a factor, 3 is a factor, 9 is a factor, and 27 is a factor. 4 to the 4 is 2, 5, 6. So if 1 is a factor, 2 is a factor, 4 is a factor, 16 is a factor, and 2, 5, 6 is a factor, and we've got one before, which is 32. Okay, so we got p squared, so we've got p and p factors, and we have p squared, which is a factor, and we've got p to the n, which is simply p, p1, p2, p3, p to the n. Okay, so we've got 3 factors here. We've got 4 factors. We've got 5 factors. We have 2 factors. Why is that? We've got 3 factors rather. Moment of madness. And then we have n factors. So the theorem is, if we have something p to the n, we have n plus 1 factors. And I think that this shows. Okay, so we are asked to find how many numbers have 16 factors which are odds and in between this inequality. Okay, so let's see if we can get rid of this. Okay, so we may have more than one n. So the numbers are going to be of the form, we could have just p to the 15, p to the 1, and q to the 7, or we could have p to the 3, q to the 3, we could have p, q, r to the 3, or we could have p, q, r, s. Okay, so let's just check to see if these give 16 factors. So that definitely gives 16. 2 times 8, that definitely gives 16. 4 times 4 definitely gives 16. 2 times 2 times 4 definitely gives 16. And 2 times 2 times 2 times 2 definitely gives 16. So you should be familiar with this property. So say for instance we've got 2 squared times 3 squared. Let's do 3 to the 3. So this has 6 factors. This has 12 factors, not 6 factors. Nearly made the mistake myself. We add 1 to the power. We add 1 to the power of each of them and multiply. So for instance, 5 squared times 7 to the 6 have 3 times 7, 21 factors. Okay, so you need to be choosing values for these. So for instance, let's go for the p to be 5 times 3 to the 7, and using a calculator we can do 3 to the 7. Get my calculator fired up. Okay, 3 to the 7 multiplied by 5. Okay, this is obviously too big. This is obviously too big. So that gives 10,935. Let's try one more. Let's try this one. Let's try what we've got. 3 times 5 times 7 times 11. 3 times 5 times 7 times 11. That gives 1055. So we're getting closer. So when you submit your solution, make sure that you describe each part of my solution to get full marks, and then you'll need to provide an answer to the question. Good luck.